So, and I did this last year, I want to do this year as well, because it's a little bit interesting to look back on what we actually call this day and what that means for, for the trends, actually. Because no one should blame us for not following trends in research and in this area. So if I went back as far as 2012, then it was SICS Cloud Day, headed by Safe here. Then we switched in 2013 to Cloud and Big Data Day, which we ran for 2 years. And then, in 2015, we moved to Data Science Day for 2 years. Now, we're sort of sneaking in Data Science and AI Day. I'm sort of expecting next year to be SICS AI Day, but let's see where we end up. But this tells us actually quite a lot about what we've been looking at during the years. Cloud has now enabled us to do way more sophisticated analytics. We're moving to larger and larger data sets, and we're moving towards sophisticated analytics, which basically means machine learning. And what's happened the last couple of years, both on the platform side and on the machine learning side, basically, is that we're more and more moving from, let's say, big data to also big models. And I'm not just saying that it's really, really big, deep neural networks and things like that, but also more complex models. And I think it's important to remember that although some of the focus and some of the applications that we see in newspapers and things like that might have changed a little bit, we're nowadays talking essentially about both big models and big data, because these big models typically need big data to drive them. And this is something that's going to be reflected all over the day, basically. And you can create now, with machine learning, tons and tons of super interesting applications, and they are everywhere. They're really everywhere. We have a few talks today, for example, from Lars Karlsson, who's going to talk about machine learning for smarter drug discovery. Really, really interesting application. We're also going to listen to Philip Eisen from King, talking about simulating human gameplay for difficulty prediction with convolutional neural networks. Also super interesting application. Applications that perhaps we weren't looking at all for 5 or definitely not 10 years ago. So machine learning is already everywhere, basically. But if we look at the research side on the basic algorithms and things like that, what kind of things are we in general doing right now that we will also talk a little bit about today? Well, a lot about it is about basically expanding the environment of machine learning. So machine learning works great in tons of different scenarios today, but there are lots and lots of places where we need to sort of tweak the basic setup, the basic premises, and so on for it to work as it should. And it basically comes down to all the real environments that we want to put machine learning into really, really come with lots of constraints, typically. You have time constraints, which means we might have to switch to online learning, to switch to streaming platforms and things like that. That comes with a completely new set of challenges in many cases. We also have restrictions in terms of data sources. How do we access them? Can we access them all the time? Do we have to build decentralized algorithms, machine learning algorithms, because we cannot centralize data, and so on? We have new issues with ownership, security, privacy. How do we actually protect people's privacy if we want to look at all their data and so on? So these are huge challenges that lots of people are working on right now. And this is going to continue for at least 10 years further on. We still have lots of constraints in terms of data sets and so on. We must be better at learning from small data. We need to be better to work with different types of sample bias, concept drift, and things like that. And we need to expand the scope of platforms for machine learning. Machine learning needs to run everywhere, and we need to be able to program it relatively easily so that we don't have to write a completely new set of code for every single new platform, basically. So it has to live everywhere, and it has to become a little bit more interactive. So there are lots of efforts now looking at mixed initiative, where you actually look at data together with machine learning algorithms and things like that, exploratory learning and stuff like that. And the final bullet point that I just want to lift up that's going to be a big research trend in the next few years is safety and security. I mean, when you do things based on machine learning algorithms in the real world, things have consequences, right? It comes with a cost. So how do we manage that? How do we let the algorithms explore the real world, for example? And in some cases, perhaps we cannot. We have to create this second reality, simulated environment for them to learn, for example, reinforcement learning. We have to deal with perhaps the fact that not everybody is truthful in the data they're generating and so on. So we have to look at that. And also, I think it's very important to remember that many fundamentals that we're working with within, for example, machine learning are not really quite solved. I would actually say that we don't really know, at least I don't really know, exactly why deep neural networks work as well as they do. It's a little bit of a mystery still. We still don't have really robust engineering for building machine learning algorithms, and especially when we move out into the real world, we have to switch between different trade-offs between communication, how much processing we do, what kind of privacy we'd like, and timing constraints and so on. And how to balance these things are really, really basic research issues. And something that we talked about several years is breaking up the black box of machine learning. We talked about it last year and the year before that and so on. And the basic difference between, for example, correlation and causation. Let's focus on two things today, because these are something that we're going to see in later presentations, and it's explainable models and uncertainty measures. How do we explain how uncertain models are about their predictions? Not only in terms of how much noise is there in the input, but also how uncertain are we about the estimated model. So I have two presenters, Hossein, who's going to talk about deep learning models and if the high accuracy in itself is enough. And we have Leif Jonsson, who's going to talk about latent Dirichlet allocation for interpretable machine learning using basically uncertainty measures. So we're calling this AI Day, right? So we're moving from analytics and machine learning to AI. And what does that mean? Well, actually it means one further step. Not just machine learning is just a part of AI. And we've been on this for a long, long time. We've been on this, we've been doing AI research for more than 60 years now. 1955 was the first time I actually have found any reference to it referenced. But if we're actually going to talk about artificial intelligence, we're going to have to talk in one way or another about actual agents actually acting and having an influence in the world, either by just decision support or actually making decisions themselves to control systems. And what do we need to do that? Well, we need to start considering not just machine learning, which is typically pattern recognition right now, but we also need to consider reasoning. How do we build machines that can reason about concepts, explain them to us, themselves and each other, basically? Internally at SICS, we are, for example, looking a little bit about techniques from natural language processing and so on, which you can use to, for example, build concepts just from data this is Wikipedia, I think, which we can use to build knowledge graphs that we can actually reason about. And we're trying to expand this now to a more multimodal scenario. We have lots of different data types because it's important to learn from many different data types if we really, really want to build wide AI. And not that AI is necessarily, in that sense, what we're going to talk about here, but both image processing and NLP applications. We'll have two talks today. Magnus Hagen, who is from us here at SICS, and also FOI, will talk about data science for text-based security applications. And Atelash will talk about natural language processing at Gillblad and give some examples. So, what do we need to look at to actually make real AI happen? So this is just a vague picture of what, for example, practical AI could look like. We're very good at perception now, up there. We need to get better at reasoning. We need to get better at interaction. But if you look at the bottom there, it's essential for us now to start looking about building a substrate for AI, platforms for AI that really, really can handle both machine learning and all the other different tasks within artificial intelligence. This is something that we're working on, SafeNI, for example, and it's also something that other people are working on throughout the world. We're going to have a couple of talks here from Flavio about Vega as a segment store, looking at streaming data, and Jim Dowling talking about TensorFlow and GPU support for really, really serious machine learning applications. So, just to finalize a little bit about what I said, we're going to look a lot into expanding the scope of machine learning in AI today, and just want to say that AI is a lot more than machine learning, and reasoning systems will be key. Perhaps we're going to see them more integrated in future years, and we need to look more at wide data. And finally, systems and platforms really, really do matter, and we need to start fixing them now. And with that, and the platforms, I would like to welcome Seif Hariri to introduce our first keynote speaker.